For the last question of Organic Skills Training Exercise 2, it's a simple deductive question. So over here, we have compound HC2H4Br2. So it's a simple 2-carbon compound. So 2-carbon compound, so we can just quickly do a guess and check already. There are 4 hydrogens and 2 bromine. So my first thought will be my 2 bromines on different carbon of this compound. And as a result, I get my 1,2-dibromo ethane. Alternatively, I can put both bromines on the same carbon, right? And this will be your 1,1-dibromo ethane. Okay, so for simple deductive like this, if it involves only 2 carbons, you can just immediately do a quick guess and check. So let's think about in terms of the reaction, because we are supposed to explain for the chemistry involved. So in this case, it is likely is a halogenal alkane. When you heat it with NaOH aqueous, nucleophilic substitution is going to happen. Alright, so as a result, you'll get a diol. It's either you get the OH at position 1 and 2, so this is your ethane, 1,2-diol, or you can get the 2 OH on the same carbon. Okay, in this case, when the 2 OH are on the same carbon, just take note, this is a very unique type of alcohol. This is what we call a germinal diol. Okay, I will highlight to you later on what's so unique about a germinal diol. So, moving on to reaction 2 then, this compound J then forms an orange precipitate on treatment with 2,4-DMPH. The reaction with 2,4-DMPH will be your condensation reaction. Typically, it tests for your aldehydes and ketones, right? It tests for your aldehydes and ketones. Now, so for the earlier part, what functional group can we identify from H? H must have 2 alcohol groups. Okay, because you have 2 halogenal alkane, largely you have 2 alcohol groups. Now, this therefore throws something like a contradiction, because you see in J that you have an aldehyde or ketone, but what you have is actually a diol. It turns out that germinal diol is a very unique alcohol. Germinal diol, on heating on itself, alright, when heated or on leaving it on its own, has a high tendency to undergo dehydration. Okay, so this is the disparity, right? So J supposedly has 2 OH groups, but it also has an aldehyde ketone. So it can undergo some form of elimination, self-condensation, to form an aldehyde ketone. And how does this process go on? So let's take a look. So we have 1,1-dibromo ethane, nucleophilic sub, NaOH, we get this. Now what happens is that the 2 OH groups are inside by to each other. So one of the OH and the other H will condense out to form water. Alright, so you can see the one I highlighted in yellow will come as water. And as a result, you have to form a bond with this oxygen, one more bond with this oxygen. This bond is gone. And you therefore end up with an aldehyde. And it is because of this aldehyde functional group that can give a condensation with 2,4-DMPH. Okay, some of you may be wondering, where is this covered? Okay, this is one of the unique alcohols that we mentioned in the beginning of our alcohols lecture notes. So you can see your lecture notes, we did cover this germinal diol part, but it was not emphasized. So again, like I said, there are some question contexts that may be foreign to you. The important thing is for you to fall back into the fundamentals, right? Nucleophilic sub, so you have 2 alcohol functional groups, and then you have aldehydes and ketones. So the only way that aldehydes and ketones can be formed is that when the two alcohols must combine together to form an aldehyde. Okay, the two alcohols must combine somehow to form an aldehyde. And the only way you can do that is that you have to remove a H and OH so that you can form a double bond with the oxygen. So in this case, this reaction undergoes a form of condensation to remove water. Okay, that's the end of question 3.